Okay, allow me to take you through this problem so that we can be able to attempt that exercise if you have any challenges. This question is a normal one in terms of what we need to do, except the last question here, where there is a requirement that we apply the knowledge of sampling distributions. I will just demonstrate how we are supposed to do one, then we proceed. So how do we get this? Which answer is here? Probability that this monthly income of one person, that is X, is bigger than, more than 21,400 will be equal to probability that. Now we must transform the X to the Z the usual way, and this should also happen to this value here, 400. From here, we must put the mean, which is here. So this is 200, 0.25. Then we divide by the standard deviation, which is the square root of 792.2142.9. Actually, we can even write it somewhere separately because you need it. You can say sigma is equals to, let me get this, square root of that 7922142. That's 7922142.9. So if I get the square root, I get 6158.09. I don't even need to use the decimals. So that is it. This will now be equal to the probability that Z is bigger than, I work out that is 21,400 minus 200, 0.25. That is equal to the 11,375. Now divide by 6158. So that becomes 1.8. Yeah, 1.85. So which we are supposed to read from the tables, and this would be 1 minus 5 of 1.85. Yeah, I mean you read directly. Why? There's a rule I have always explained. Always draw this graph. Try to place where your Z is. My Z is somewhere here. This 0.0. This is the area we are looking for. And as long as it is less than 50% of the area, always take 1 minus that 5. 5 is just a function, so I take 1 minus. I read from the tables, the normal tables, which are here. 1.85 is here, 1.8 here. Then I go to 5 column 5 here. So I'm left to just use that 0.9678. 0.9678. So this would be then 0.0322. This is what we have up here. So this is in agreement. So you do this next one, which is similar to this one, the same way. The only difference is that now it is asking for less. And this one you have done previously, so it should not be an issue. Now on part 3, we are now applying the binomial distribution, which we said when a variable is having a binomial distribution, it has that notation. Then we say the expected of x is equal to np, n multiplied by p. So this step gives us the p-value. So the p-value there is 2.975, and the n is this. Why? I am deleting the equation. This value here is the same as this one here. So we are talking about the same thing, only that in the number 3, we are looking for the number. So 300 multiplied by this gives you the area here, or what we should enter here, which is actually this value, NP, binomial distribution. Now we move to the last one, which is number 4, and this is where I think the challenge is, and allow me, maybe I could have shifted, but we don't have much space here. But let me first illustrate. So we are going to say the probability that 21,400 is less than, remember this is the mean, so x bar, which is less than 21,100. So this is a trick here. We have x bar, not x. So we know that the mean of x bar is always the mean, the usual mean, but the variance or the standard deviation of x bar is actually the standard deviation of the original data divided by root n. So that is the trick. So we are saying here we are going to have the same kind of a thing, but we are going to deal with this relationship. So I want to do this in a space where I don't know whether you can do it over. Sorry, this will not help us. Let me put in a clean straight without deleting this. So because that has failed me, allow me then to do this, to erase this part. I just leave that so that we do everything else here. So we have erased that. So we now try to do this thing up here. So I will now use the set, but now this will be the set 21,100, and as the mean, which is 20,025 over now 61,58 divided by root 100. This is the 100 here. So this would be less than set, it should be less than 12, not 12, but 21. 2100 minus same 200 0.25 over the same 6158 over root 100. So this will become P. This now we need to do the computation. 211,400 minus 200025. That becomes to 13 something divided by 11 at 7.5 divided by 615.8, because when we do the square root, we will get you'll get that correct? Let me do it again. 211,400 minus 20,025, so that 11,000 something divided by 6145. So just a minute. 5.8. So this is a very big number. 18.47. That is strange. Said less than let me see the other one. That one is quite large. 21,100 minus 200, 0.25. This is 12 divided by 12,000 something divided by 615.8. So this becomes 19.6. This one is quite straight. I'll check why it is that large, but the answer there will be approximately 0. I can almost tell without even going further. Need to check something else. Yeah, this is strange because of the values are large, but anyway, if you read this from the tables, 9.6, 19.6 minus 5 of 18.47, it should become 1 minus 1, which is 0. So this is now slightly different. Of course, when rounded off is about 0. However, I suspect technical problem which I'm going to check. So, but the method is just done like that. Process So you can still try it using that method, except you wait for me to program the question if there is a turmoil. Thank you.